On that note, let's get started. So we did not have a lesson yesterday or last Friday in honor of Pi Day. Just kind of a review from lesson 2. This would have been a few days back then. Chance experiment, event and outcome. Those were the terms that we should have seen throughout. Chance experiment, anything has a chance of happening. Whether it's equal chance or not an equal chance, it's still a chance experiment. We're going to talk about that today. An event, like something happening and then like predicting if it will get heads and then actually doing it and getting an outcome would be the result of that. So just some terms, again, that's on page 17. We're going to continue rolling on probability here. Corbin, would you read the first question?
Which game would you choose to play? Explain it using game 1. You flip a coin and win if it lands showing heads. Game 2, you roll a standard number cube, and if you win, win if it lands showing a number that is divisible by 3.
All right, I'll give you 1 minute to answer that one, then be ready to explain to the class which one you chose and why. 2 options there. You got to pick one of those games. Jared, which one are you picking?
Game 1.
Why?
Because you have a likelier chance to win.
Prove it.
Because it's a 50% chance if you hit heads or tails, but it's only
All right, you're going to win if you show heads. That happens half the time, right?
in game number 2, it's only a 2/6 chance you'll win, so 1/3 chance.
Well, what numbers are divisible by 3 on a dice,
3
Jared?
and 6.
3 and 6. That's a total of 2 out of 6, which is a third. Obviously, 1/2 is a better probability of happening. So Jared made the correct choice. Yes?
I said game 2 because technically all numbers are divisible by 3, they just don't all come out.
That is a good point.
Yeah, that's now.
Yeah.
That is a good point, but I'm assuming it means evenly.
Uh-huh.
Evenly.
Yeah, no, no.
Question 2, Kinley.
No.
Okay. For each situation, list the sample space and tell how many outcomes there are.
All right.
Oh, sorry.
No, go ahead. I just want to define sample space. Sample space means all the possibilities. Okay, so if you ever see the word list the sample space on the directions, that means you need to list all the possible outcomes. Sometimes that can be quite a few. Okay, now Kinley, continue.
Okay. A. Han rolls a standard number cube once. B. Claire spins this spinner once.
Continue. It's 3 more.
C. Kieran selects a letter at random from the word quote unquote math.
Quote unquote.
D. Magi selects a letter at random from the alphabet. E. Noah picks a card at random from a stack that has cards numbered 5 through 20.
All right, so this is going to take a little time. I'll give you a few minutes. List the entire sample space. That means every possibility for each question. And then it says how many outcomes. So 2 parts. 1, write them all out. Part 2, how many do you have? Okay, need to do one together or you got it? One together. Which one?
Let's do D.
Quote unquote math. All right. So what are all the possibilities from drawing a letter from the word quote unquote math?
M-A-T.
M-A-T-H. So I have to list them out. There are 4 possibilities. That's what you need to do for the rest of them.
That's so hard.
I'm glad you picked that one.
How will I ever do it?
I don't get it.
Yeah, I thought it was like 4 to 26 or something, because like 26 letters in there.
It's a math.
It's math.
The alphabet is the next one.
I'm so confused.
We did see
From the word
From the word math, there's only 4 letters in math.
Yeah, I mean, if you want to use all the letters in the alphabet to spell the word
Oh, so 25%.
math.
25%.
No, it's not asking you anything. That's the answer. We're done.
All the possible outcomes
It's not asking the probability of drawing the letter M or anything.
NATA.
That's what we wrote down.
Good job.
Yeah, way to answer it after we did, Georgia.
That made no sense.
Wow. It's so
Georgia, you're giving me a headache. Maybe it's the glasses.
Sorry.
Wait, Mr. Mobrat, what if we gave you a big enough headache you'd have to leave because you're sick?
You can't get rid of me that
Now I
easy.
know my ABCs.
I'd power through it just for you.
We'll find a way. Mr. Larson, Mr. Milbrand's bullying us. He needs to be taken away.
But then they just assign
He's bullying us too. He won at Pie Face, and that's just illegal.
Mr. Scott. I'm a little sad.
Yeah,
I'm glad you're
I got a
sick.
2, and then I got hit.
Josh, you done? All 5 of these?
Yeah,
No, you're not.
I'm done.
You haven't even turned the
I'm
page
done.
yet. Got them all? All right. We're going to start rolling then.
I was tempted to write and now I know my ABCs next time we do it.
Jonas.
I'm not writing all the ABCs.
That's fine. Hey, what do you got?
1, 2, 3, 4, 5, and 6, and then 6.
So sample space is all of them. That's a total of 6 outcomes. Brooksy.
For B, I got R, E, T, Y, and that equals 4.
Good. Did letter C already, right, Georgia? You want to do it again, or are we good?
I think we're good.
All right, D. Colin.
A, B, C, D.
Yeah, that's fine.
Do A through C.
Okay, I'm not actually going to write them all out. I'm assuming you got them. That's a total of 26.
We can't forget that now I know my ABCs.
Could you say them without singing it?
Probably not. A, B, C, D, E, F, G, H, I, J, K, L.
Okay, I was just asking. E.
X, Y, Z.
Jessa.
5, 6, 7,
All the way to 20? How many total?
16.
That's a lot. Down to 20.
Yeah.
No, because
You're including
5, 6, 7, 8,
The only 4 numbers that aren't included would be 1, 2, 3, or 4 out of 20.
18, 19, 20.
Should be 16.
16.
If you include 5.
4 numbers aren't included.
The only numbers that aren't included out of 20 are 1, 2, 3, 4.
Aha, I told you.
Number 2, Josh.
Next, compare the likelihood of these outcomes. Be prepared to explain your reasoning.
All right, I'd like you to do A here for me, Josh. Would you read it, please, and then answer it?
Is Claire more likely to have this minor stop on the red or boys? Doesn't matter, they're both the same.
So what word from last unit, or last section, equally likely as not?
I know.
Why can't we just write the word E?
Because it wasn't a choice. Equally likely as not. How do you know? They're both equal. They're both equally likely. They're the same size, same shape, whatever you want to say. B, Jonas. Would you read it, please, and then answer it?
Is Kieran or mine more likely to get the letter T?
That makes no sense.
I think equally likely.
Yeah, Kieran.
Not likely.
All right, so let's look at this one. Kieran would be 1 out of 4. Maya has 1 out of 26. So who's more likely? Kieran. 1 out of 4 is a better probability than 1 out of 26.
But like,
Georgia, C, please.
Is Han or Noah more likely to get a number that is greater than 5?
All right, let's look at Han. He was A. What's the probability of him getting a 5, Georgia?
low.
6. And you know what?
That's not a probability, Georgia. Tell me 6, that means 600% of the time. How many 5s could Han get? How many 5s do you see here?
1.
Out of?
6.
Thank you. 1 out of 6. Chesney, what's Noah's probability of getting a 5? Out of? 1 out of 16. So who's more likely? 1 out of 6 or 1 out of 16?
I thought it said.
It's greater than 5.
Oh, greater than 5. Scratch that.
I was confused.
Georgia, back to you.
Oh, what are you not?
How many numbers are
1, 6.
No.
greater than 5?
1.
1. Doesn't say greater than or equal to. It says greater than 5. The only number that's greater than 5 is 6. So we could have left that one. Chesney, back to you. Numbers greater than 5. 15 out of 16. So that would obviously then be Noah. Question number 3. Kinley.
Number 3. I read twice today.
Yes, well, you keep talking, so I keep calling on you.
Okay, 3. Suppose you have a spinner that is evenly divided showing all the days of the week. You also have a bag of papers that list the months of the year. Are you more likely to spin the current day of the week or pull out the paper with the current month?
All right. So you have a spinner that has all the days of the week on it evenly. You have a bag of papers that has all the months of the year on it. So what's the probability of getting the current day of the week on a spinner? 1 out of 7. Obviously, it could only be one day to be correct out of 7. How about the correct month of the year? 1 out of 12. So which one's more likely?
Day of the week.
Day of the week. So the spinner would be more likely. Are you ready on the bottom of 22? Are there any outcomes for 2 people in this activity that have the same likelihood? Explain your reasoning. So was there any probability, let's look at these 5, that you could have come up with that would have been the same probability?
B and C.
Josh.
B and C.
So give me an example of the problem.
Okay, so like, you pick a letter.
Who?
Claire.
Claire?
And Kieran pick a letter.
Yep.
4 letters in both of them.
There are 4 letters in the spinner and drawing a letter at random.
Yeah. So
Okay. So you're good with that? B and C. Spinning the spinner, getting 1 letter, and drawing a letter out of those 4, quote unquote math, would be the same. All right. Question 3. Gonna need a little help with this one. Kellen's gonna read it for me.
Okay. Your teacher will give you your group a bag of paper slips with something printed on it. Repeat these steps until everyone in the group has had time. As a group, guess what is printed on the papers in the bag and record the guess on the table. Without looking in the bag, one person takes out one of the papers and shows it to the group. Everyone in the group records what is printed on the paper. The person took out the paper, puts it back into the bag, shakes the bag to mix up the papers and passes the bag to the next person again.
All right, so we're gonna add person 0 to this list. Person 0 is gonna be Josh.
Oh,
Josh, you're not gonna get the draw. But you're gonna guess what's in here. This is my bag. So before we even draw, you gotta guess what the sample space is in here.
Ink. I guess there's ink on that paper.
What's in here? You gotta guess.
Paper.
With what on it,
Ink.
specifically?
Writing.
Draft.
I think,
There's
Oh.
words.
like.
What are we drawing
A
out?
card.
What?
Like a card.
A card.
A rock with a ring.
You guys are not following what you're supposed to be guessing. Like, what are you drawing out of here? Like, is it numbers?
A letter.
Is it colors?
Oh, is this like guess who?
Color.
See, you're Your cards have
Colors.
I said.
All right, colors. You said ink.
Yeah. There's
All right,
ink on
Kellen,
paper.
come on up.
Alrighty then. Like this is guess who? Do your cards have letters in them? You're not wrong.
If there's ink on the paper.
It doesn't want you to draw first.
I don't know, does it? I think it wants you to
supposed to
guess
draw.
first.
All right,
No, you're person zero.
Yeah, you're person zero, Josh.
no looking.
It's ink, I guarantee you. There's ink on the
Show
Oh,
it-
there is
show
ink
it.
on the paper. I can't. I don't know
Eh?
where I am.
The letter N.
I said letters and ink.
Ah, it's over there.
Letter N. Would you like to guess the sample space now? What's in here?
26.
So all the letters of the alphabet.
I hope. Wait,
I didn't say the outcome. I said the sample space. So
I don't know.
Wait, what did Josh guess?
Ink.
you said ink.
Yeah.
Pretty much gonna
ink-
cross that out.
Ink would be right, would it not?
Sample space. Little refresher. What should I be guessing again?
Sample space. So all the possibilities. What's
Yeah,
what?
26, right?
So there's
That's what I'm guessing.
that's the number of outcomes.
Yeah.
You have to say A, B, C, D.
If you think it's every letter of the alphabet, you'd have to list them.
A, B, C, D, F, G, H, I, J,
So you think it's A through Z.
E, F, G,
All right.
H, I-
Person two.
Counting right, because I have to.
Brody. Go sit down.
Okay.
Okay, I got it right though. I guessed ink and I guessed letters.
I think Josh got it right.
And paper, so I got all
It
of them.
wasn't letters.
There was letters.
There are letters in the bag.
Okay. D. Do you think it's still A through Z?
Yeah.
And so you're not changing your mind at all.
Could be a
Okay.
word.
A through A.
Yeah, I
Not
think
ink.
those are the letters of the alphabet.
There's not 26 in there.
Oh.
Maybe just
So you're changing your idea for what's in here.
We could have
Do A through Z still.
You still think it's the same?
No, it's not.
I think she just got lucky.
yeah.
Me too.
I think it's the first 19 letters of the alphabet.
That was a random number.
Did you figure out what letter N was?
You can draw A.
Ooh. Okay.
I think it's not the
Is it under the?
No, it's not.
I think it's just N and D.
Oh, really?
I think
Hey,
it's
we
just N
still
and
got
D.
it right. It's still A through Z.
What do you think?
Just N and D.
All right. So she's narrowing down.
Yeah, Sophia.
She thinks it's just the letters N and D in here.
Yeah.
You're gonna draw it. It's not gonna be N and D.
All right. So the question is,
Not vowels.
how was guessing the sample space the fourth time different than the first? What do you think? Who has an idea?
They're different.
It changed because all of them, two were N, one was D, so then we thought it was gonna be
Well, who do you think had it easier?
the last one.
The last person should, right? You know more information. Now, is this correct? We don't know yet.
Yeah, it is.
I doubt it.
Maybe.
Okay, but it should get narrowed down. If we would have had everybody in the classroom draw, we should have been able to focus it on just maybe certain letters.
Okay, so there are 26.
How does that?
I don't
What
know.
could you do to get a better guess of the sample space?
Look at the bag.
More people? More experiments? More people draw? Absolutely. Look at all the papers in the bag. Were any of your guesses correct?
Can you just like?
So here's what's in the bag.
How are we
What's the
that
first
lucky?
90 letters? Not 90. First
Then why
first
does N
19
get picked
letters
so
of the
much?
alphabet. First
Oh,
19
that's 15.
Yeah.
15 letters.
Wait, why did N get picked so much then?
Because it was.
Same reason if you'd flip a coin, you get 5 heads in a row. Sometimes it just happens.
50%.
It didn't get shook up
That's
enough.
weird.
50%
Why is
That
it-
sucks.
Yeah, it's a little sucks.
So the probability of drawing an N should have been 1 out of 15. The probability of drawing 2 N's in a row would be 1 out of 15 times 1 out of 15, which would be should happen 1 out of 225 times.
But we do it.
In theory.
We're legendary.
If I would have like
In theory. All right. For each of the outcomes if these were all cut up, same size, you know, if one would be twice the size, maybe that would affect the outcomes. But right now, would any of them, or are all of them equally likely? Yes. They're all in there once. Out of 15 letters. Next one we've kind of answered a couple times now. Use the sample space to determine probability that a next person would get the same outcome as person one. So if you draw the same letter, somebody else would be
Yes.
exact probability.
115.
1 out of 15. Got a 1 out of 15 chance of drawing the same letter as the last person. All right, again, some terms I'd like to discuss. Probability is likelihood of something happening. It's always going to be between 0 and 1. Okay, because 0 means it never happens. 1 means it's always going to happen, so it's usually between there. Can't be above 1, can't be below 0. So your fractions, for instance, always got to be between 0 and 1, or if you have it as a decimal or a percent, between 0 and 100%. Other terms, random, pretty self-explanatory. And then sample space, remember we have to list them. So before we go, I'm going to give you a couple more probabilities before we look at the homework. I want you to answer the following 5 questions. Probability of rolling a 7 on a dice?
What?
0.
No, I want you to do these independently.
Where though?
Oh, yeah, what if it's like?
Just anywhere.
Is
Is
it
it
one
just
of
like a
those special
6-sided
ones
dice
that
or is
you-
like,
Regular dice.
Okay.
okay,
Next one is the probability of drawing a red card out of a deck of cards.
It could be 0.
Shh, don't say them out loud, please. I want everybody to try these. The next one, again dealing with cards, probability of drawing a jack in a deck of cards.
Yeah, there's 50 cards in it.
I hate that game.
Wait, what?
52 cards.
Yeah, just throw them on the ground.
That's when you get to slap people's hands.
It's like, hey, you wanna play a game? Oh, go pick them up.
Next one's the dice again, probability of rolling an odd number or a 4. And the last one. Kind of getting our head of ourselves on this one, but I just want to see if you can get it. Probability of flipping a coin and getting 2 heads.
How many
No.
times do you flip the coin?
Twice. Flipping it twice. What's the probability of getting heads and then a heads?
So what is a red name?
Red card out of a deck of cards. Normal deck. No jokers.
Oh,
No jokers. All right. Everybody had a chance to at least get a couple of them, hopefully. Brooks, which one do you think you got?
The bottom one.
Oh. What do you got?
I got 1/4. Yeah.
1 out of 4th is correct, and again, we're not to that point yet, but if you flip a coin, there's basically 4 things that could happen. I can get heads and heads. I could get 2 tails. I could get 1 of each, depending on the order. Those are the only 4 things that can possibly happen. How many of them have 2 heads? Just 1. 1 out of 4 is correct. Kellen,
Let's see, I got 0 for the first one.
can't happen.
What if you found-
Can't roll a 7 on a standard die.
Oh.
Oh, man, okay.
Georgia,
I got the second one.
probability of getting a red card.
Two, half of 52.
So 50%.
So can we just say half?
Oh, yeah.
Yeah.
Yes, it would be 26 out of 52, but then we always reduce it.
50%.
Half. Chesney.
I got the third one,
Jacks. Okay.
4 over 52.
Can you reduce that for me? There's 4 jacks, 1 of every suit out of those 52 cards.
2 out of 26.
1 more?
13. 1 out of 13.
Yeah, there's 1 jack of every suit of 13. Yep, and then always reduce. Last one, Brenna?
2/3.
Yeah, rolling an odd, there's 3 odds, and then it adds another option of getting a 4. So that'd be 4 options out of 6. Reduces 2/3. Always reduce, always reduce. All right, take a look at the homework. Top of page 25, on to page 26. Again, the first one, guys, it is not asking you for probability. Sample space, that means you have to write them out. Write out all the possible outcomes, that's all you're doing. Question number 2, it's asking about the alphabet again. I'm assuming you can handle that. Problem number 3 is just like what we got done doing. Kind of like that dice one where I said roll an odd number or a 4. Here it's talking about selecting a random month and getting one that starts with the letter J, so that's what you're analyzing. How many J months we have. If you get stuck, it says write them out. Write the sample space out so you know how many start with a J so you don't miss one. Question number 4, I think we can handle that. Question number 5. Jonas, would you read number 5, please?
Here's a diagram of the base of a bird feeder which is in the shape of a pentagonal prism. Each small square on the grid is 1 square inch. The distance between the 2 bases is 8 inches. What will be the volume of the completed bird feeder?
All right, remember the formula for volume?
Area of the base times height.
Area of the base times the height. Now, what does this mean? That Josh read. Distance between the 2 bases is 8. Yeah, they could have just said,
You,
did I say Josh?
yeah.
Jonas.
That's the height.
That's the height. That's a fancy way of saying the distance between the 2 bases, right? They could have just said the height is 8. That's all that means. Okay, so you know the height. So find the area of this shape. Again, a few different ways to do it. You could do a whole rectangle, then subtract the triangles. You could split it up. Doesn't matter to me. You have to get the area of the base right. Okay, and question number 6, surface area. Surface area. Area of every side if you want. How many sides we got there? 5. Or you could do the perimeter of the base times the height plus the top and bottom area if you want. A couple different options since it is a prism.